Alright, in Exponents 3 notes, we're going to talk about what happens when you have a power of a power. Alright? Basically what that means is, if you have an expression that's already has an exponent inside of parentheses with another exponent outside the parentheses, this kind of expression right here, alright, anytime you see the parentheses with an exponent outside, that's when you know you're going to use this law. Alright, and this law says that if you have a power of a power, or you could also say it as an exponent to another exponent, the rule says that we multiply the two exponents. Alright, so let's do that. Example number 1 says a to the third, inside parentheses, raised to the fourth power. Well, that's an exponent to an exponent, or that's a power raised to another power. Well, by the rule, it says that we could really just take x, or a to the third power times fourth power. And 3 times 4 is equal to 12. Alright? So that's how we do those. Now, where it sometimes gets tricky is when you have more than one thing inside the parentheses. Alright? So like in this parenthesis, I have a 3 inside there, and I have an a to the 0 power. Well, this one's not too bad because I know that a to the 0 power cancels to 1, okay, or reduces to 1, or simplifies to 1. So that's really not even there. We really just have a 3 to the third power. Okay. And mathematically, that's not a law or anything like that. That is just 3 raised to the third power. So 3 times 3 times 3 equals 27. Okay? Don't get this mixed up with our exponent laws. Yes, it's an exponent, but you're just doing the regular rules of exponents. If you have an exponent of 3, we're taking 3 times itself 3 times. Okay? So, that's the answer to this one. Now, what about number 3? Number 3's got one of those special exponents as well. That special exponent is the fact that this whole parentheses, no matter what's in there, a negative 4a cubed, whatever, if you notice that this whole parenthesis is raised to the 0 power, then that can be simplified to just 1. That's by the very first law that we talked about as far as exponents go. If you have a 0 exponent, it simplifies to 1. Flip your page over to the back side and find number 4. Number 4 has a coefficient out in front of the parentheses, and the parentheses is squared. Inside the parentheses, I have a bunch of other stuff. Alright? Well, I want you to know that if you have this, okay, if you have this coefficient out in the front, you kind of need to save that for the last. Let's do this exponent problem first. Now, with a bunch of stuff inside the parentheses and an exponent outside, it's kind of like this exponent out here has power over everything that is inside the parentheses. Alright, so it's kind of like saying that we have, so it's like saying that the 8 is going to be squared and the x to the negative 5 is going to be squared. So if we break it all apart, this is going to look like 5 times 8 squared times x to the negative 5 squared. Okay, we can even put all this stuff in parentheses. Alright? Well, if you do that, or if you have a situation like that, then we can go ahead and reduce all this down. Not really reduce it down, just work out your laws. This is just 5. We'll save that for the end. 8 squared, okay, that's not an exponent law. It's just working out an exponent. So 8 to the second power is 64. And then x to the negative 5 squared, that's your law that we're working on. That's a power to power, or an exponent to exponent. So that's really saying x to the negative 5 times 2. And if we work that out, 5 times 64 is 320. X to the negative 5 times 2 is negative 10. Alright. Now, real quick, got to finish cleaning it up. We have a negative exponent. Alright. Again, the negative 10 is only attached to the x. So that's the only thing that needs to be moved down to the bottom. Alright. So this solution is actually going to be 320 over x to the 10th power. That's your simplified version. Question number 5. Look at all that mess right there. Again, if you have an exponent outside the parenthesis, it's almost like it has power over everything that's in there. And you can separate it. You have like -6 squared and then x squared. Same thing over here. We've got a 2. That's going to be attached to both of those things. So it's really like saying -3 squared. And then wait a second, can I get rid of this guy right here? That guy can cancel to 1, or it can simplify down to 1. Alright, so now let's work these equations, or let's work these exponents. -6 squared is 36. X to the 1 squared is really just x squared. And then -3 squared is 9. Now, since these two are coefficients, they're two regular integers, I can also put them together, multiplying. 36 times 9 is 324, and then put your x squared back on there. And as long as you don't have negative exponents or zero exponents, that's as simplified as you can get. Question number 6. Again, that guy outside the parenthesis is power over everything that's inside there. Well, there's something that I can get rid of. Alright, so -9 squared, y squared squared. And let's break this one up. This 3 cannot be over the power of everything in there. So we'll get a -3 to the 3rd, x to the -7 to the 3rd, and y to the 3rd. Okay? Now let's go ahead and work out these things. That's going to give me 81. Okay? This is going to give me -3 cubed is a -27. So let's go ahead and move those together. We'll have 81 times a -27. And let's go ahead and start putting these in order too. I have a I have a y expression right there, and I have an x expression right there, and a y expression right there. Let's go ahead and work out this x expression. This x expression is going to give me x to the -7 times 3. Well, that's just x to the -21, because again, I'm doing my exponent to exponent law. This y guy right here is going to be y to the 2 times 2, and that's going to be y to the 4th power. And then this one is just y to the 3rd. Okay? So that's all of my exponent law for exponent to exponent. Now what I have is I have some multiplying going on here. I don't have any more exponents outside of parentheses. Alright? So what I have here, these two are just coefficients. Alright? These two coefficients can multiply together to give you a -2,187. I still have this guy by himself. We'll mess with him later. The negative exponent. And this is a product of powers. This is your multiplying two exponents, or multiplying two expressions with exponents. And if you remember, that's the same thing as saying y to the 4 plus 3. Right there. Alright, well, y to the 4 plus 3 is y to the 7th power. Now I can simplify this negative exponent. He's bad, so let's put him in the basement. So our answer is going to end up being -2,187. That guy's going to go to the bottom, so we'll draw a fraction bar, put him on the bottom, and then y to the 7th stays up top. And that's your simplified version.